Hello, in this section I will integrate using use substitution, and then I will use the change of variable to evaluate a definite integral, and then I will evaluate a definite integral involving an even or odd function. So yeah, so pretty much use substitution, and then there's like these other techniques that can make integrating more easier. So yeah, so what is use substitution? You can say use substitution is just another technique to integrate more complex definite and indefinite integral. When would you use substitution? I would say anything with a radical or parentheses raised to a certain power. So for example, integral of 2x parentheses x squared plus 1 raised to the fourth times it by dx. Or something like this, the integral of 3x squared times it by square root of x cubed plus 1 dx. Did you know that you can change the boundaries for definite integrals to make integrating much more easier? So yeah, you can change the integrals. You don't have to, but you can. So the rule for a change of variable for definite integrals is this. The integral from a to b f of g x times g prime of x d of x is the integral of g of a to g of b of f of u du. So it's all you got to do is once you have your u, substitute your old boundaries into that, and then I'll explain it when I do one of the examples. And then if you have an even or odd integral, there are shortcuts you can apply to make integrating more easier. So yeah, so if you have an even function, by the way, what is an even function? An even function is even function is something like it's symmetric to the y-axis, so it would be if you plug in a negative x and your outcome is positive f of x, that's even. And then if you have an odd function, you could apply this rule, and just note that odd is symmetric to the origin. So yeah, so I think the rule for symmetric to the origin is f of negative x gives you an outcome at negative f of x. Okay, so I will explain those when we do an example. So for right now, let's focus on use substitution on example 1. So this is there's no boundaries, so this would be indefinite. What is the integral of x squared plus 1 raised to the power 2 times by 2x dx? So this is not what I would not, I mean, you could FOIL it out, take the integral of each term, but that would take forever. But what you could do is just do use substitution. The hard part for use substitution is figuring out what is your correct u. So you can do let's say okay, the reason why u of 2x would not work, so let's say you use u as 2x, right? And then you do du, which means you take the derivative, right? So what is the derivative of 2x? It is 2, and then don't forget about the dx. So the reason why use substitution of 2x would not work is because you don't see a 2 dx in your problem, right? We see a 2x dx, and we see an x squared plus 1. So that's when you have to like use another u. So the correct u would actually be x squared plus 1. Okay, and the reason why is because when you take the du, or the derivative, it would be what's the derivative at square? It's simple power rule 2x. what's the derivative of 1 or a constant? It's 0, right? And then you add a dx. Now, the reason why this works is because do you have a 2x and a dx in your problem? Yes, we do. We have it here. So that's why it would work. So how you would write this is integral, and then you can replace x squared plus 1 with u squared, or u to the second power. And then you can replace this 2x times dx with du, because du is technically 2x dx, right? So you can replace this with du. Okay. Then we're going to simplify. So what is the integral of u squared? Simple power. So it's going to be u, and then it's going to be 2 plus 1 over that power, which is 2 plus 1 is 3. And then don't forget you have to add, because this is there's no boundaries, you have to add plus c. Okay, so this simplifies as u cubed over 3 plus c. And then you can replace u with x squared plus 1 to the third all over 3 plus c. Okay, so that would be your final answer. You can also write it as 1/3 parentheses x squared plus 1 raised to the third power plus c. That's the same thing. Okay, so that is example 1. Let's move on to example 2. So we have the integral of 5 times by the square root of 5x plus 1 dx. So we're definitely going to do U substitution because it has an integral. I mean, what is this called? A square root. So it's going to be you'll say u as 5x plus 1. Then I'm going to see if this works. So you have du, which is what's the derivative of 5x? 5. What's the derivative of 1? 0. And then don't forget the dx. So this u is perfect because in the equation, do we have a 5 dx in the problem? Yes, we have a 5 here and a dx. So that's why you know that U substitution will work. So this square root of 5x plus 1 can be simplified as the square root of u. And then this 5 and this dx can be replaced with du because du is 5 dx, right? Now, how do you take the integral of square root of u? Well, if you would like, you can rewrite this as a power, right? So square root of u can be simplified as u to the 1/2, right? Because u to the 1/2 is the same thing as square root, and then du. So from here, you can easily take the integral because you just apply the integral rules. So it's going to be u to the 1/2 plus 1, or 2/2, divided by that power. So 1/2 plus 2/2 is the same thing as 3/2. And don't forget the plus c. So this is u to the 3/2 divided by 3/2. You have a complex fraction, so you can simplify this as u to the 3/2 divided by 3/2. Then I would cross multiply, so that would be 2u to the 3/2 over 3, and then plus c. Okay, then your final answer, you just have to replace u with, what did we say u was? 5x plus 1. So your final answer is, it could be expressed as 2/3 parentheses 5x plus 1 parentheses raise it to the 3/2 plus c. Okay, so don't forget the plus c if you don't have any boundaries. Example 3. Definitely you could use U substitution, and the U, I'm going to substitute U with x squared plus 1. Let's see if this would be the appropriate U substitution. So if I take du, the derivative of x squared is 2x. the derivative of 1 is 0, and then don't forget the dx. Now, this one, this is going to be kind of different now because you could use change of variables, but because we don't have any boundaries, I don't think we have to. This is the correct u. We'll definitely use x squared plus 1, but the thing is, we don't have a 2x dx in our problem. We only have an x and a dx. We don't have this 2. So what you're going to have to do to get to make it like x and dx is get rid of this 2. So how to get rid of this 2 is you're going to multiply both sides by the reciprocal of 2, which is 1/2. Okay, so you kind of have to like manipulate it to make it what you want. So on the left side, 1/2 times du is 1/2 du. And then 2x dx times 1/2, well, the 1/2 and the 2 cancels. So you're just left with x dx. Now this makes sense because now we have an x and a dx, so it works perfect. So it's going to be integral, and then you can replace x squared plus 1 with u squared. And then what you're going to do is you're going to replace x with x dx, not just regular du, but 1/2 du. Okay. Now, to make life easier, you can move your integral to the left side. That's part of the integration rule. If you have a constant, which 1/2 is technically a constant, you can put it aside and then deal with that later. That's what I'm going to do. Then let's take the integral of u squared. So that is going to be u to the 2 plus 1 over 2 plus 1. But don't forget the 1/2. So you're going to have to times this by 1/2. And then don't forget the plus c. So that's going to be 1/6 u to the 3rd plus c. And then what you're going to do is replace u with x squared plus 1. That's 1/6, and then replace u with x squared plus 1 to the 3rd plus c. Okay, final answer. So this is example 3. Let's move on to example 4. So what's the integral of x times by radical x squared minus 1 times dx? So let's do our u substitution because we have a radical. So what should we make our u as? I think the best thing is to substitute u with x squared minus 1. Let's see if this is correct. So you take the du or the derivative. So what's the derivative of x squared? 2x. And then the derivative of -1 is 0. So, and then don't forget the dx. Now, just like the last one, wait, are these example 3 and example 4? They're not the same. Okay, I thought they were the same. Okay, so just like example 3, this is the correct u, but the thing is, we don't have a 2x dx. All we have is an x and dx, right? So we have to get rid of this 2. So to do that, you're going to multiply both sides by 1/2. So on the left side, 1/2 times du is 1/2 du. And then on the right side, 1/2 times 2x dx, well, the 1/2 and 2 cancels. That's what we want. So you're left with x and dx, right? So that works out perfect. So it's going to be square root, and then you're going to replace x squared minus 1 with u. Then what you're going to do is replace x and dx, not just regular du, but 1/2 du, right? Because you multiply both sides by 1/2. Okay. And then this 1/2 is a constant. You can put it outside. Worry about that later. And then the square root, it's going to be square root of u du. And then how you now we got to take the square root, the integral of that. So to make life easier, you can rewrite this as a power. So square root of u is equivalent to saying u to the 1/2 du. And then what's the integral of u to the 1/2? Well, it's going to be u to the 1/2 plus 2/2, or 1. And that would be 1/2 plus 2/2 is 3/2. So that's u to the 3/2, and then 3/2. Let me simplify this before I do times by 1/2. So that's going to be, I'm going to just do the bracket method. So here's 2, this has a 1. We're going to multiply by the common denominator, which is between 1 and 2, the common denominator would be 2. So 2 times u to the 3/2 is 2 to the 2, it's 2u 3/2. And then 2 times 3/2, the 2's cancel, so you're left with 3. And then don't forget, you got to multiply it by 1/2. Yeah. Okay. And then plus c. And then that simplifies as, well, the 2's cancel, so you're left with 1/3. And then you can replace the u with, we said that u is x squared minus 1. Raise it to the 3/2 plus c. And that will be final answer. Okay, now let's do a problem with boundaries. Okay, so this one, we could use the change base formula. Not change base, change variable. So if you go back, oops, you have that option. You could also do it the long way. It doesn't really matter. It's really up to you. Where is it? Let me go back. Okay, change a variable. So this is the change of variable. Your boundary is going to be changed. And I'll show you what will be your new boundary. So first, we're going to do u substitution, and we're going to set u as x squared plus 1. Then you're going to take the du. So the du is going to be 2x dx. Thing is, we don't have a 2x dx. We only have an x and a dx, so we have to get rid of this 2 by multiplying both sides by the reciprocal of 2, or 1/2. So that's 1/2 du. And then on the right, 1/2 times 2, that's x dx, correct? So it's going to be, you can replace x squared plus 1 as u to the 3rd, and then you can replace x with dx as 1/2 du. Now, what would be our boundary? So you don't have to, later on, we're going to learn about fundamental theorem calculus. So that's only, if you haven't learned about fundamental theorem, I'll show you. So what would be our new boundary if we want to use the change variable? So your new boundary is going to be, so we said that u is x squared plus 1, right? And then this is like our lower boundary, 0 is like our lower, and then b is like our upper. So you're just gonna substitute in those boundaries into u. So let's start with 0. So what is u of 0? That is going to be 0 squared plus 1. So that would be 1. And then let's do our upper boundary. So our old upper boundary is 1. So u of 1 is 1 squared plus 1. And then that would be 2. So my new lower boundary is 1, and my new upper boundary is 2. So that's how you that's how you get your new boundaries, by substituting your old boundaries into u. Okay. So now let's simplify this. This 1/2 is a constant, so you can put it outside, and it's u cubed du. So what is the integral of u cubed, u to the third is u to the fourth over 4. And then don't forget about the 1/2, so you're going to times that by 1/2. So that's 1/8 u to the 4, right? Now, you can do the you don't have to replace u with x squared plus 1 and then do the fundamental theorem. You could just apply it. So so what I'm going to do is apply the fundamental theorem because we have boundaries. So you do fundamental theorem is like f of b minus f of a. So this is like your a, this is like your b, right? So it's like you put the upper boundary first minus the lower boundary. So it's going to be 1/2, and then you're going to replace u with your upper boundary, your newer upper boundary, which is 2 to the 4th minus 1/8 to the 1 to the 4th. Okay. So what is 2 to the 4th? It is 16. So that's like 16 over 8 minus what is 1 to the 4th? 1 times by 1. So that's 1/8. So 16 minus 1 is 15/8. So your final answer is 15/8. And this, you don't have to do it this way. You could have just used the old boundary and then plug in your u and then do the fundamental theorem. Either way, both actually will work. But this is just like a shortcut almost. Okay, let's move on to example 6. We have a boundary from -2 to 2, so we definitely have definite intervals, and it's x5 minus 4x cubed plus 6x raised time to the dx. So this one you could do the long way. You could take the integral for each term. I would not do U substitution, right? And then do the fundamental theorem. So you would do f of 2 minus f of -2, right? Once you take the integral of each term. Or what we could do is apply the even and odd function to make life easier. So our function is f of x equals to x5 minus 4x cubed plus 6x. So this is technically an odd function. So there's 2 ways you can determine it. If you plug in f of -x, and your outcome is positive f of x. No, let's take that back. If it comes out negative, that's how you know it's an odd, and odd is symmetric to the origin. There's another way I like to do it. Since this is a polynomial, I look at the powers. So this rule states if all your powers are odd, then it's an odd function. If all your powers are even, then it's even. If all your powers is a mixture between odd and even, then it's neither. So that's like a little trick that I remember. So if you look at the power x5, that's an odd. The power -4x cubed is an odd. The power 6x to the 1 is an odd. So they're all odd, so that's how I know that it is an odd function. Right? So the rule states if it's an odd function, it just becomes 0. That's pretty cool, right? You don't have to. So where is it? Yeah. So if your function is an odd with a definite integral, your integral is just going to be 0. So your final answer for this one is just going to be 0. You could do the long way. If you don't believe me, take the integral of each term. For example, if the integral of x5 is 1/6x6, the integral of -4x cubed is -4x4 over 4. The integral of 6x is 6x2 over 2. And then you would apply the fundamental theorem of calculus, so -2 to 2. Do your upper boundary minus your lower boundary, and you would still get 0. It's a bit time consuming, but yeah, this is a perfect shortcut. Okay, next last one, example 7. The integral from 0 to 3 of x squared dx. So is this odd or even? This is definitely even, because you could do it this way. So if you plug in f of negative x and your outcome is positive, in which our case it would be, right? If you plug in negative x into this function, or our function is x squared, yeah, it's definitely even. And you know that x squared is a parabola, right? So you know that it is symmetric to the y-axis, which means it's even, right? So this concludes it's even. So the rule states to do integrals of even is it's going to be 2. You're going to put a 2 here. I don't know why, but that's what they say. You have to put a 2 here. And then your lower boundary is going to be from, I think the boundary stays the same, so 0 to 3, and then x squared dx. But let me double check. So yeah, if it's an even, it's just, you could put a 2 here, and then your lower boundary is 0 now, and then your upper boundary is still the same. And then it's just regular f of x dx. Okay, so let's take the integral of x squared. So what is the integral of x squared? It's 1/3 x cubed. And then because we took out a 2, you're going to multiply this by 2, right? So that's 2/3 x cubed raised to the 0.3. And then just apply the fundamental theorem. So it's going to be 2/3, 3 to the, do the upper boundary, 3 to the third, minus, if you want, you can put a bracket, 2/3, 0 to the third bracket. So 3 to the third is 9 times 3 times 3 is 9. 9 times 3 is 27. Times it by 2 is 54 over 3 minus 0. And then 54 over 3 is just 18. So that would be your final answer. Okay, that does wrap it up for this section. Thank you. Bye-bye.